All right, this is Mr. Gillum, and today we're going to start solving equations by using square roots. All right, and but before we get there, before we get to the actual equations, what we need to do is we need to practice our just basic operations with square roots. We're going to do a little bit with multiplying and a little bit with dividing today. Okay, and so before we get too carried away, you need to know what the radical is. Okay, it's the actual square root sign. Okay, and it might not just be a square root; it might say cubed root, fourth root, fifth root. Okay, but today the radical is the root sign, okay? You're just going to be doing square roots today. The radicand is whatever's underneath the radical, all right? So if I got the square root of 2 here, the radical is this square root sign, and the radicand would be 2, okay? That would be the radical and the radicand. All right, just so you all know what I'm talking about when I say radicand, radical. Okay, now let's talk about some of the things that you can do with square roots. Okay, square roots you can separate. You can separate them. Okay, if it says the square root of AB, you can separate that and you can say it's the square root of A times the square root of B. Or likewise, you could say the square root of A times the square root of B equals the square root of AB. You can put them under the same square root sign if you want. Okay, and we're going to use it both ways throughout this lesson. Okay, and so for example, the square root of 18 could be the same as the square root of 9 times the square root of 2. As you can see, you can simplify that, 3 times the square root of 2, which is nice. Or you could even say, okay, this is what we're going to really be doing. The square root of 9 times the square root of 2 equals the square root of 18. Okay, it works both ways. And that is a huge concept for today. Okay, when you have two roots and you multiply them, you can multiply what's underneath. All right, and pretty soon we're going to have numbers outside. Those are a different thing. All right, we'll talk about that more later. The quotient property says if you have the square root of a fraction, what you do is you take the square root of the top and you take the square root of the bottom. Okay, same way it goes backwards too. If you have the square root of A over the square root of B, you can make them under one big square root, A over B. Okay, this is going to come in handy when, not just this example, but like say the square root of 1/4. If you know what the square root of 1 is over the square root of 4 is, okay, it's going to save you a lot of time, 1/2. The square root of 1/4 is 1/2, and that's what the quotient property says. You can separate that into two square roots if you'd like. Okay, and the same way goes for this example here. This is really the square root of 2 over the square root of 25, which is the square root of 2 over 5. Okay, and that's the best way to do it. All right, you can separate it, and like I said, it goes both directions. Okay. The rule for today, and this is really the key about whenever we're dividing with square roots, okay, and we're going to call it rationalizing. All right, we're going to call it rationalizing the denominator. And what we're doing is actually we got to get rid of the square roots in the denominator. Okay, they're not allowed. Okay, and so we're going to start with some examples of multiplication, but we're going to get into the denominators. And so what you need to keep in mind is that you can't have square roots in your denominator on your fractions. Okay, I'm going to teach you how to get out of that. But first we need to start doing some factor trees, okay? And what I want to talk about first is just the variable x, okay? And by now you're in Algebra 2, you know a few things about the variable x. In front of x, there's a 1 that you never write, but you assume it's there and you know it's there because 1 times x is still just x. The same way with a fraction, you know it's over 1 because you know x over 1 is the same as just x because anything divided by 1, it doesn't change. And even we could go even farther and say the exponent on this x is a 1, but you never write it because you know anything to the first power, it doesn't change it. And we could even go farther than that, and we could even say plus 0 if we wanted to, because it's not there, but if we wanted it to be there, it could be because it's not actually going to change anything. Okay. The same thing kind of works with a square root. Okay, there's really a little 2 out here that you don't see that it's assumed to be there. Okay, it's a little 2. Okay, and if you think about the word square root, it sounds a lot like squared or to the second power. Okay, squared. The square root of 80 now. I'm sure you've done it in many different ways in the past, but what I want you to practice, and we're going to get back into factor trees here in a little bit, is I want you to simplify these square roots using factor trees. And what a factor tree is, it's when you find numbers that multiply to be 80. Okay, and you keep simplifying all the way down until all you have left is prime numbers. Okay, so for example, for 80, I know 40 times 2 is 80. Every single prime, you have to circle it. I'm going to be looking for that on papers. 40, I know 20 times 2 is 40. I'm going to circle that prime. That's an even, so I know 10 times 2 is 20. And I know 5 times 2 is 10. So I'm going to circle those primes. And the neater you do it, the easier it's going to be for you. Okay. Now that little 2 out in front of that square root, okay, I wrote it in there for a reason. Okay. You're never going to see it, but you just need to assume that it's there. All right. What it means is for every 2 little prime factors in there, you can pull one out. Okay. You could say, I can cross those 2 out. And now instead of being under the square root, I have 1, 2 on the outside of the square root. Okay, and so I'm looking for any pairs. I see a pair there, a pair of 2s. So I can cross 2 out and pull 1, 2 out. Okay, I got the first 2 from those 2 that I crossed out, and the second 2 from those 2 that I crossed out. Now this 5 here doesn't have its pair. So what happens to him is he has to stay under the square root. Okay, he doesn't have a way to get out. So he stays underneath. And I know 2 times 2 is 4, so this is 4 times the square root of 5. So when you simplify the square root of 80, what you get is 4 times the square root of 5. And if you type it in your calculator as the square root of 80, or whether you type in the square root of 5 times 4, you get the same answer. Okay, but we are not using decimals, we are using square root notation. Okay, and so let's look at the square root of 98. This one's not so bad. Okay, we're going to look for 2 numbers that multiply to get 98. I know what's even, so I'm going to say 2 times 49. 2 is a prime number. The only thing that I can multiply to get to 2 is 2 times 1. So only even prime there is. 49, I know 7 times 7. Those are both primes. So now I've got all my factor tree done. I'm looking at the roots here. For every 2 they have in common, I can pull one out. So since there's 2 7s down there, I can pull a 7 out. This 2 doesn't have a pair, so he's got to stay under the square root. We'll leave him under there. All right, so 7 times the square root of 2 is going to be my solution for the square root of 98. That's how I want you to simplify it. Looking at the square root of 54 here, I'm doing the same thing, factor tree. 2 numbers that multiply to get 54. I know 6 times 9 is 54. Neither of those is prime, so I'm not circling anything yet. 3 times 2 is 6, so I'm going to circle those prime numbers. And 3 times 3 is 9. So I got my factor tree here. And the problem won't have a little 2 out there, but you got to understand there's a 2 out there that they don't write. Okay, that means for every 2 they have in common here, like that 3, you can pull one outside the square root. The 3 doesn't have another 3 underneath, and the 2 doesn't have another 2 underneath. So they both have to stay under the square root. I still have that 3 times 2 in there. So now when I simplify, all I have is just 3 times the square root of 6. Okay, this 3 had to go there, this 2 had to go there, these 2 canceled out and gave me 1 on the outside. All right, and so as you practice these, you get better at them, but that's how we're going to do our square roots for now. All right, now let's talk about that multiplication property we talked about earlier. Okay, what it says is you can multiply square roots together and put both of the numbers under the same square root. And if that doesn't make sense, what this really means is what we could have is the square root of 3 times 5, which is really just the square root of 15. Okay, so the square root of 3 times the square root of 5 is just the square root of 15. And just to make sure that we can't simplify it any, okay, I always want you to simplify your answer. I know 5 times 3, those are both prime. There's no pairs. So I know that the square root of 15 is as low as it gets. That's my solution. All right. When you multiply something like the square root of 21 times the square root of 3, once again, I'm just multiplying 21 times 3 under the same square root. Okay. That's all that's happening here. And so now I really have the square root of 63. But, okay, you got to be careful. You got to rationalize. Now, here's the nice thing about showing your work on this. Okay, if you don't know what 2 numbers are to multiply to get 63, okay, use the 2 numbers that you just had. I know 21 times 3 is 63. So let's just factor tree it there. 21 times 3. There's my 3. That's a prime. And 7 times 3. That's a prime. And that's a prime. Now remember what I said about in the factor trees, okay? We know square root of 21 times the square root of 3 is the square root of 63. However, that's not simplified form. There's a little 2 out there that you don't see. So every 2 factors on the inside, you can pull one out. The 7 does not have a factor. So 3 times the square root of 7 is going to be my final answer there. Okay, 3 times the square root of 7. Looking at some more here. Okay, same way, and I showed you that little trick if you can't figure out what two numbers multiply to get a number. Okay, this is really the square root of 12 times 6. All right, it means the same thing, and the multiplication property tells us that. Okay, the product property. And so what we can do is say this is really the square root of 72. All right, and if you're having trouble figuring out two numbers that multiply to 72, all right, you know 12 times 6 equals 72 because that's how you got 72 in the first place. Okay, or you could do even, if we want, I'll show you two different ways. I know 8 times 9. Okay, we should get the same answer, so let's work it out both ways. I'm just making my factor tree now. Show you that it doesn't matter. All right, and whether I'm taking the square root of 72 and I do my factor tree this way on the left or this way on the right, okay, I see I have 2 2's, 1, 2, 3, 3 2's, and 2 3's. So either way, you still get the same prime factorization. All right, now that little 2 out there is telling us for every pair I can pull one out. So I'm going to pull a 2 out, and I'm going to cross those out so I don't forget which ones I've used. I'm going to pull a 3 out. And what I have left underneath that doesn't have a pair is a 2. So I'm going to leave a 2 under there. I know 2 times 3 is 6, so really I just have 6 times the square root of 2. All right. But then you might come along and come across a problem where it says 3 times the square root of 3 times the square root of 7. All right. And when I go back to this x, I mean, we talked about it, there's really a 1 in front of it. There's really a 1 in front of anything you want there to be a 1 in front of, because 1 times anything doesn't change the value. So really, if you want to worry about it, okay, you can't multiply this 3 times the inside of the square root. You can't do it. But you can multiply 3 times the number in front of the square root, but it really is just a 1. 3 times 1 is 3, okay, and square root of 3 times the square root of 7 is going to be square root of 21. All right, so the numbers outside the square roots multiply by the other numbers outside the square roots. The numbers underneath the square roots multiply by the numbers underneath the square roots. Okay, you can take the 3 times the 7, and if there's no number there, you can always take the 3 times the 1. Okay, just to make sure, 7 times 3, okay, those are both prime. There's no pairs in there. So 3 times the square root of 21 is going to be my final answer right there when I multiply those. All right, let's get into a little bit more complicated because you're going to get some of these on your homework. Okay, same idea. You need to take the numbers in front and multiply them together. 2 times 1 is 2. And the numbers on the inside, 20 times 6 is 120. Now, it's pretty obvious to me that I don't think this is in the simplest form. So what I'm going to do is I'm going to factor tree this guy right here, 60 times 2. Or I could have used 20 times 6, which is what I got in the first place. Either way is fine. I'm going to simplify this thing all the way down. And so I got my factor tree here. And what I'm going to do before I start crossing stuff out is I got to keep in mind I already have this 2 out here. So I'm going to write my 2 first because that one came from right here. We already had a 2 on the outside. Now I'm going to start crossing stuff out. There's another 2. And I don't see any more pairs. There's no other 5s, no other 3s, no other 2s. So all that stuff's got to stay under the square root. 5 times 3 times 2. All right, so now all I got to do is simplify. 2 times 2 is 4 times the square root of 30. All right. And the problem, this first 2, one more time, it came from right there. All right, that's where that 2 came from. So it was already out there. Okay, so let's look at this example here. This time 2 root 3 times 6 root 5. Like I said before, the numbers on the outside get multiplied together. That's 12. The numbers on the inside of the roots get multiplied together. That's 15. From there, all you got to worry about is simplifying. I know 5 and 3 are both primes. They're both going to have to stay under. There's nothing I can pull out. So my final answer is just going to be 2 root 15. Sorry, 12 root 15. All right. So now let's just get on with the good stuff here. We got 6 times 6. 6 root 5 times 6 root 35. The outside number is multiplied, 36. The inside number, now here's what I recommend you do. I'll show you the little shortcut here. Okay, instead of actually multiplying those numbers together, let's just keep them separate. Let's just keep it 5 times root 35, 5 times 35. Okay, and I'm just going to circle that in there because it's a prime. It's like one of my factor trees. Okay, and if you don't understand this, that's all right. You can do it the long way. That's fine too. Okay, but these are my primes underneath here. Okay, whatever number 35 times 5 is. Okay, just to show you. 175. Okay, I'm just going to factor it into 5 and 35 anyway. 175, those are my two factors anyway. So instead of actually multiplying it out and using my calculator and figuring out what that big number is and then trying to figure out what multiplies to get there, just use your 5 and your 35 as your factors, your first parts of your factor tree. Okay, so I know now I got a 5 and a 5. Okay, this 36 is already out there. I'm crossing out my two 5s and pulling that out. And on the inside, I still have a 7 left. 36 times 5, 0. See here, 36, 5, 0, 3, 18, 180. Okay, so I have 180 times the square root of 7. Okay, and so if you didn't get that little trick, that's all right. You can do it the long way. That's fine too. I just thought I'd show you that. Okay, now let's talk about the quotient property. And what the quotient property says is the square root of this number is really the square root of the top over the square root of the bottom. So really we could write this as the square root of 16 over the square root of 25. I know what the square root of 16 is, it's 4, and I know what the square root of 25 is, it's 5. So all I got to worry about is my solution is 4/5. Looking at the next one, same idea. I know this is really the square root of 1 over the square root of 64. The square root of 1 is 1, and the square root of 64 is 8. And that's something that I don't know why a lot of people just don't know that. The square root of 1 is 1. 1 times 1 is still 1, okay? So that's just one of those little things about square roots you need to keep in mind. The square root of 1 is 1. Okay, one more. Let's just look at it. Square root of 4 over the square root of 16. That's really just 2 over 8. Not 8. 2 over 4. But you can reduce that to 1/2. And now let me show you something else here. Okay. Before we even separated it, what we could have done is simplified inside and said the square root of 1/4, which is really the square root of 1 over the square root of 4. That's 1/2. And that would have saved us a chance. We would have saved us from that second simplify. So whatever you want to do, that's fine. Okay. You can simplify two numbers that are under square roots. You can't simplify a number outside of square root with the number inside the square root though. So either way you get 1/2. All right. Now, this is called rationalizing a denominator. Okay, rationalizing a denominator. The rule is, and I circled it at the bottom of your page, you cannot have a square root in the denominator. So what we're going to do is we got to figure out a way to get rid of that square root in the denominator. Okay, and this kind of goes back to adding fractions. All right, when we add 1/2 plus 1/4, we know we need a common denominator. Okay, and obviously it would be 4 this time. Well, to get to that fourth, I really take this times 2 over 2. 2 times 2 gives me the 4, and 2 times 1 will give me 2. 2/4 is the same as 1/2. Okay, this little step right here, this is the key to simplifying radicals. Okay, what we really did was we just multiplied the number by 1. 2 over 2 is the same as 1, so we didn't change the value of it. All right, and that's what we need to do with these square roots. Okay, because there's not an equation, there's no two sides to multiply by, we can only multiply by 1. And we know anything divided by itself is 1. So to get rid of a square root, I'm going to show you this little trick. We're going to multiply the square root of 7 over the square root of 7. Okay? And really, anything divided by itself is 1. So we didn't really change how much it's worth. We're just going to write it a different way. Okay? So like 5 million divided by 5 million is still just 1. All right? I'm going to show you this as well. When I take 2 times the 1 here, I get 2 on top. And root 3 times root 7, that's root 21. Okay? On the bottom, what I could do is I could say the root of 49 and simplify it. But what really it is, okay, this is a shortcut. Okay, the square root of, say, 900 times the square root of 900 equals 900. Okay, whatever the number underneath, if it's exactly the same, that's what the solution is. So square root of 7 times the square root of 7, without doing any work, I know it must be 7. All right, and now that I don't have a square root in the denominator anymore, I've got my solution. Okay, so it's a little confusing, but we're going to practice. Don't worry, we're going to practice. Same way with this next example. Okay, I got the square root of 3 in the bottom. I can't have square roots in the bottom. Mr. Gillen will not allow it. So what we're going to do is we're going to have to multiply by the square root of 3 over the square root of 3. Okay, and when we do that here, I'm just going to go ahead and use this negative on the top. We have negative 5 times 1, which is negative 5, and the square root of 8 times the square root of 3, which is the square root of 24. over, and now that little rule is going to come in handy because whenever you multiply two roots that are the same radicand, the radicand is actually the answer, 3, just like that. Now some of you clever students might notice that 3 and 24 can cross cancel. However, 3 is not under a square root and 24 is, so you can't be cross canceling those. We could cross cancel the -5 and 3 if there was something to cancel because they're both out of the square root. However, we can't cross cancel the 24 and the 3. However, even though I've rationalized the denominator, Mr. Gillum should be pretty happy with this, because there's no square root in the bottom. You need to simplify your solution here. So what I'm going to do is I'm going to take this square root of 24. I need to figure out how to simplify it. 12 times 2, 3 times 4, 2 times 2. Okay, so I got my prime circled, but keep in mind you already have that -5 out there. Okay, that -5 is already out there. So I'm going to write that first. Then I'm going to start cross canceling out. Okay, 2 and 2 makes a 2. 3 and 2 is going to have to stay on the inside. And then I simplify -10 root 6. So really this part becomes -10 root 6 all over 3. And like I said before, you can't cancel the 6 and 3 because the 6 is under the square root and the 3 is not. All right, let's look at one more here. And this kind of like is a combination of rules. This is really the square root of 5 over the square root of 2. Okay, and we just kind of practice that a little bit. Nothing we can simplify yet, but we can't have the square root in the denominator. So what I'm going to have to do is multiply the top and bottom by the square root of 2. Okay, and I know square root of 5 times the square root of 2. I know this now from earlier is the square root of 10 over 2. And I'm going to tell you again, you can't cancel that 2 with that 10 because they're not both under the square root sign. All right, so make sure you don't do that. All right, we're almost there. I'm going to show you two different ways to do this problem. Okay, the first way, the traditional way, we can multiply the top and the bottom by the square root of 2. Okay, and that'll get rid of that square root down there. What we'll have is 4 times the square root of 24 all over 2. And then we could reduce a little bit. That makes it 2 square root of 24. But really we can factor that. Okay, got all my prime circled. I already got that 2 outside. Okay, that's where that one came from. And now I got another 2 from my canceling out. And that 3 and the 2, they don't have pairs, so they stay underneath. 4 root 6. Okay, and there's my solution. However, I'll show you a little better way to do it, a little quicker way to do it. Notice how on the top we have a square root of 12, and on the bottom we have a square root of 2. Okay, and it's all held together by multiplication. I'm going to rewrite the problem here. I'm going to do the same problem a different way. Okay, any numbers that are under the square roots can cancel them out. Okay, so instead of doing all this work, what I could do is I could just reduce 12 over 2. It becomes a 1, that becomes a 6, and look what happens. 4 times the square root of 6. Without doing all that extra work, I get the same solution. Okay, so one more time, the roots can cancel out. I get the square root of 1 on the bottom, which is just 1. On the top, I have the square root of 6, and there's no need to write this over 1 because that's never written that way. It's just the 4 square root of 6, and that's it. Okay, so either way you want to do it, if it makes sense the old way, do it that way. If you like the new way, the cross canceling, do that. Okay, and similarly with this one. Okay, and we kind of already talked about this a little bit. Look, we can cancel out this stuff in here. Don't make it harder than what it is. This is the square root of, this becomes a 2 and a 1, really just 2. We could put 2 over 1 if you want, but really that's just the square root of 2 over the square root of 1, which is just the square root of 2 because this is just really 1. That's our solution, okay? And we already know 16 divided by 8 is just 2, so really it's just the square root of 2. So however you want to think about it, okay, anything under the square roots can cancel. We know the quotient rule also says we could have the square root of 16 over the square root of 8. And we could apply this rule right here and say, well, they're both under the square root, so we can cancel them. Square root of 2 is left. However you want to come to the answer, that's fine. You can do any way, one of those ways.